So you can see this being an issue of debate in, well, highly polarized debates basically about what causes what. But smoking and lung cancer is one of them. Another one would be the role of the availability of firearms in a society and the fact that people tend to kill each other in those societies. You can say, well, those firearms, the fact that they're available isn't the only cause that people are dying in a society. Of course not. But still, there's a useful way in talking about a causal connection between the two, which basically means that there's a set of factors which together make it more likely that people die than if that set of factors were absent in similar circumstances. So we are not, when we're saying that guns kill people, we are not saying that only guns can kill people and without there being guns people wouldn't die anymore. No, we're saying something else. We're saying that, well, the likelihood of people dying increases in a meaningful way if in all the factors that are present and might finally lead to people dying, guns are present as well. We have a more precise way of talking about what I was just saying, and which is an INUS condition, which is described in the Steinovich article as well, which makes for a more nuanced perspective on exclusivity, right? So exclusivity basically means that you're dealing with a condition that is both sufficient and necessary for the other condition to occur, right? So if guns were to be both sufficient and necessary, then that would mean that as soon as somebody has weapons available, people would start dying, and people wouldn't start dying without there being weapons. That's saying it's both sufficient and necessary. That would mean it's the exclusive cause, but that's not actually what we mean when we talk about the relationship between weapons and people dying. What we mean is somewhat more subtle than that, and that we can describe by using that INUS condition. So an INUS condition is an insufficient but non-redundant part of an unnecessary but sufficient condition, right? So basically what you're saying is, I take all the factors together. We're not dealing with a factor by itself, right? We're not just saying the presence or absence of guns. You need guns, you need people that pull the trigger, you need people that stand in the way of the bullet, etc., etc., etc. The powder has to be dry in the gun, or however you call it with modern guns, etc. There's a lot of factors involved that you all need for them to be sufficient to cause the effect, right? So you take that, all those factors I just mentioned, you put them in a ball, and that collection of factors is sufficient for killing people. So if you have a person with the intent to kill somebody, you have a person with a gun that's loaded, the gun works, he's aiming in the right direction, people aren't dodging away when somebody shoots. Those are all connections, those are all factors in that part of that condition, which together are sufficient for killing somebody. It's not necessary because there are other ways in which people can die as well. What we then mean by the INUS condition is that the availability of firearms in that whole collection of factors I just mentioned is a non-redundant part. So it's a crucial element. If you take it out, the effects would be different. And that's basically what we mean when we talk about causes and effect, right? Causal relationship, we talk about INUS conditions. We say there's a bunch of stuff that needs to happen before there's a sufficient condition for the effect to occur. And part of that bunch of stuff is this specific thing, in this case the availability of firearms, that's non-redundant, meaning in this case that it will raise the probability of somebody dying in a significant way. So what we've done is we've looked at those classical criteria, right? So we had the exclusivity, I'm sorry, where is it? Oh, here, yeah. We looked at the exclusivity criteria and we've been critical about it. So when is it a case of exclusivity? Do we actually mean that something is only a cause if it's both necessary and sufficient for something else to occur? Well, we've looked at that critically and we've seen that, well, that's not actually what we mean when we talk about causal connections. Because a lot of the stuff that we see as causal, smoking killing people, guns killing people, etc., is not necessarily a sufficient and necessary condition. It's something else. It's an INUS condition. So that means it's a non-redundant part of a unnecessary but sufficient condition. So a whole bunch of stuff that together is sufficient for resulting in a certain effect, and of which one specific thing is non-redundant. So whether it's in that collection of stuff is different from when it is not, right? It's a non-redundant part of that collection of factors. All right. The slides, by the way, if it's too small for you to read, look up the slides on Canvas, so you can zoom in as much as you'd like there. All right. So we've looked at classical criteria. We've been critical of the third criterion of exclusivity and tried to be more nuanced about it. But it kind of passes the buck from exclusivity to what do we mean with exclusive? Now we're justified in asking the question, what do we mean with non-redundant, right? So how do we know that something is non-redundant, that it made an actual difference whether that factor was there or not? And for that, the concept of counterfactual is useful. So we check for that non-redundancy by looking at counterfactuals. And a perfect counterfactual would be to know what would have happened if everything were the same except for that thing that we are interested in, right? So if everything in my life were the same except for me having proper hair growth, that would be an ideal counterfactual, that everything would have occurred the same except for my hair growing longer than it would, or more places on my head. Then you would have the perfect counterfactual. Everything is the same except the hair on my head. And then you would be justified in saying, well, the effect of being bald or having hair is such and such, because we can compare the actual situation with the counterfactual, with a perfect counterfactual situation. The problem, of course, is that such a perfect counterfactual doesn't exist, right? There's only one me. There's the bald one and not the hairy version. So it's impossible to have that perfect counterfactual, basically. But I'm just giving you an ideal version of what we would need to have for checking that non-redundancy in an ideal way. Well, that would be a perfect counterfactual. Everything is the same except for the stuff we're interested in. So we can do something else instead. And now things should start to look familiar to you, because that's actually why we we use experimental design, right? Because it doesn't give us a perfect counterfactual, but it gets us close. It gets us close because of random assignment, right? So, for example, if you were interested in the effect of hazing or initiations on liking for a group, you could use experimental design, right? You could just draw people at random from the population and assign them at random to different conditions. And in so doing, you're not creating equal groups, but you are creating groups in a way that allows you to assess the likelihood of getting differences from the procedure by chance alone, right? That's basically why we use random assignment. And we already talked about this, right? This is how Ronald Fisher invented basically the design of experiments. He said, let's do random assignment instead when he worked at an agricultural station. We talked about it. I think Danny mentioned it as well in the debate. And so he purposefully introduced the role of chance in experiments, because it made us able to quantify the likelihood of finding differences between groups just by chance, just being the result of random assignment. And that's useful, because it allows us to draw stronger conclusions about what causes differences between conditions, for example. It allows us to quantify, well, are those differences between those conditions caused by just the random assignment or by something else, something we manipulated in the experiment, for example. And that's useful. So if you were to draw a causal graph, which is done in the Pearl chapter, in the other chapter as well. Basically what you do with a directed acyclic graph, or a DAG, is to all the different factors that are potential causes of the stuff you're interested in. So in this case, the degree to which people fraternize with each other is caused by how intense the initiation is, whether people have family who used to be members of the same fraternity as well, and the degree to which people dislike being alone are all different factors that would cause this effect, right? People who dislike being alone more are more likely to be part of a fraternity. People who have family at the same fraternity are more likely to be want to be part of that fraternity as well. And people who have gotten a more dislikable initiation or hazing procedure somehow want to be part of that fraternity even more. So if we're just interested in one of those potential explanations, so how intense the hazing or initiation is on how likely it is people want to join that fraternity, then we need to take those other factors out. And random assignments allows us to do that, right? Because the only factor then influencing initiation intensity is then random assignment. And that means that all potential ties between this factor, that factor, and and initiation intensity as well are cut, right? So somehow my PowerPoint skipped over this one. So if we're looking just at those three potential causes, those three are interrelated as well, right? So whether you have family at the fraternity and whether you dislike being alone will also influence the likelihood of you choosing to be part of an intense hazing procedure or an intense initiation procedure. And we need to cut those ties, right? We need to cut the potential causal connections between those two alternative explanations and the one we're interested in. And we do that by random assignment. Random assignment basically means that the only thing that determines how intense your hazing or initiation was is chance, basically. And that's the beauty of it. And that's why random assignment to conditions as part of that experimental procedure gives us something close to a perfect counterfactual. Right? All right. Just another way of talking about counterfactuals before we go to the break. Bear with me for a couple of minutes more. So an experimental design isn't possible in a lot of cases, right? And potentially research using an experimental design makes for less ecological validity, right? So you can manipulate some aspects of people in hazing or initiations, but for ethical reasons you can't make it as realistic as possible. So perhaps you should use existing groups, use quasi-experimental research. Then the question is, what provides the counterfactual in quasi-experimental research? Right? So we have experimental design, you have an experimental condition and control condition, and we know that the control condition provides not a perfect, but a very good counterfactual because of that random assignment. In quasi-experimental research, the counterfactual is still the other group, right? So you use two existing groups. You have one group of members of a fraternity that does intense hazing and a group that's member of a different fraternity that does less intense hazing, and you can look at the differences between the groups, right? How much do people bond with each other in one group compared to the other? And you can think about, well, that might be due to the fact that the hazing was more intense in one group than the other. So you've suffered more extreme hardships with each other, so you bond more with the group that you suffered those hardships with. Could be a conclusion. But a threat to that causal conclusion is the fact that we use a less perfect counterfactual, right? We used an existing group. So other stuff might have happened to the other group that would explain the difference as well, such as attrition and regression towards the mean and all the other different threats to causal inference that are listed in the Stanovic article. I'm not going to talk about all of them because they should look familiar on the basis of year one, and you're going to talk about them in the tutorial as well. So they're going to be covered at length there as well. Finally, so what I wanted to do is change your perspective, right? I wanted you to get a good sense of what we mean when we talk about causal inference, or about causal relationship. We've talked about the role of exclusivity, and we make it more nuanced by looking at INUS conditions. And then we've asked the question, what do we mean by non-redundancy? How do we gauge whether a factor is non-redundant? Well, you need a good counterfactual. An excellent counterfactual, perfect counterfactual is impossible. A good counterfactual is provided by random allocation in experimental design. And from there, it becomes more challenging to get to a good counterfactual, right? So if you use existing groups, they might differ for different reasons than the one you're interested in. So basically you need to provide some form of matching between the groups. But there are other ways of providing counterfactual, right? So you can use a twin study as well and look at what, let's say you use, pairs of individuals who are highly similar or identical in terms of genetics, and you look at how they react to a manipulation or a treatment variable in differing ways or in the same ways, and that gives you some idea as well about the degree to which something is caused by the stuff you're interested in, or to what degree genetics or genetical makeup play a different role, or it could account for a alternative explanation.